Chapter 5. Equilibrium of a rigid body. Okay, class, today we're going to learn something fun about how engineers make sure things like cranes, bridges, and even playground swings stay steady without tipping over. Imagine you were playing on a seesaw. When your friend sits on one side and you sit on the other, if you both balance properly, the seesaw stays level and doesn't move. That's what we call equilibrium, when all the forces and turning effects cancel each other out so nothing moves. Now, to understand this, engineers use two simple rules. First, the sum of all the pushes and pulls must be zero. That means if you push one way, something else must push the other way just as much. Second, the total spin or turning effect, called moment, must also be zero. It's like you and your friend sit on the seesaw in such a way that it doesn't spin or tilt. These two rules help engineers make sure structures don't collapse or tip over. To solve these problems, we always draw something called a free body diagram. It's like making a picture of the object and drawing arrows on it to show who is pushing or pulling. For example, if we have a beam resting on a wall, the wall pushes back up on the beam, and maybe there's a weight pulling it down, like a heavy box. Different kinds of supports behave differently. If something is on a roller, it only pushes up, like a ball sitting on a ramp. If it's pinned, like a door hinge, it pushes sideways and up or down, but doesn't stop it from turning. If it's fixed, like a table bolted to the floor, it stops it from moving in any direction and from spinning. We don't need to worry about inside forces because they cancel each other out like people in a tug of war pulling on opposite sides inside a closed room. They don't affect the building. But we always consider weight because Earth pulls everything down with gravity, and we pretend all the weight comes from one spot called the center of gravity. Sometimes we also use simple models. For example, a big, complicated beam can be shown just as a line with arrows so we don't get confused by too many details. When things are connected with pins and rollers, we can make our drawing simple and only show important forces. Then, to actually solve the problem, we write simple equations. We say all the left-right forces must cancel out, all the up-down forces must cancel out, and all the moments must cancel out. It's just like making sure your tower of blocks doesn't fall over. It can't lean too much on one side or it will topple. Sometimes we see something called two-force members, where something is only pulled or pushed on two ends, like a rope or a simple stick. Those forces are equal and straight along the line. Or three-force members, like a triangle of sticks where forces meet at a point so it stays still. By using these simple steps, drawing free body diagrams, knowing which forces act on supports, and using balancing rules, engineers make sure things stand tall and safe. It's just like you making sure your toy bridge doesn't fall when you put toy cars on it.